Good afternoon. I'm a student of physics course. I'm Artem Zhikharov. I've also had 2 months internship in Eurocontrol and would like to present my presentation about air traffic flow selection of MOAC Upper Area Control Central traffic radar with the SUM tool. So, in recent years, air traffic flow density is continuously growing very fast. That's why, in the future, it will be complicated to provide qualitative air traffic control for each aircraft. For this reason, an analysis is conducted about the air traffic flow density. And one of the best ways to conduct this analysis is to perform air traffic flow selection. And this analysis assumes such possibilities like to identify the busiest air traffic flows, to represent how air traffic actually flows by the airspace, to find the busiest airspace volumes, which have a great influence on the ATC control and on the safety of aviation in general. It gives information about the busiest and most efficient routes, can help to enhance airspace design and also to give us statistical data about the number of flights which cross these sectors of airspace total. The air traffic flow selection can be produced with the help of SUM tool. It's a system of assignment and analysis at microscopic level. The main function of such tool is to improve airspace and sector capacity. The SUM tool uses the SSX files which contain flight plan data and radar data of all air traffic flows. This data is provided by the central unit flow management unit, CFMU. And here you can see the construction of SSX files. Here you can find the information about the origin of each flight and destination of each flight by ICAO code. Segment identify the name of all waypoints and the time of entry and exit these waypoints, type of aircraft, call sign, status of flight, for example, descent, climb or cruise, and so on. And the air traffic flow selection makes use of airspace gates in the SUM tool. These gates is useful for air traffic count in the corresponding airspace. Here you can see the gates which catch all traffic which are going from the Frankfurt airport and Schiphol airport. So here I would like to represent you my model of airspace gates which can catch all traffic going through the MOAC airspace. In this table you can see the description of this model, the name of the gates, the direction of this gate, geographical direction of the gates, and the gate division by flight level. So, with this tool you can create your traffic scenarios and investigate and estimate the main directions of flows and and also workload taking into account the flight level. During my scientific work, I have estimated the workload of MOAC airspace and to find the busiest entry-exit gates in this airspace. In the table, you can see the busiest entry-exit gates of MOAC airspace, and you can see the reason because near this MOAC airspace you can see the Schiphol Airport, London Airport, Heathrow, Gatwick, Stansted, London City, Frankfurt Airport, and Paris airports. And this is a more detailed analysis for Frankfurt Airport. These programs can show you the traffic for arrival and for departure. And you see for traffic departure from Frankfurt Airport, the main flows going to London Airport, to Schiphol, to the west, Scotland Island, Canada, to Paris airports. And traffic which arrives from Frankfurt Airport Canada. From the north, Denmark, Sweden, from London airports, Heathrow airports, Paris airports, and the same analysis for Schiphol airport. The same situation, for example, for traffic arrives from Schiphol airport also at the flow which are going from Central and Southern Europe, Switzerland, Italy, and also from Germany, Frankfurt, Munich, and Eastern Europe. So at the end of my analysis, I would like to say that this data can help to enhance the aerospace and can help to find solution for change the sectors of more aerospace, because the situation is very hard. The more aerospace is very busy. That's why they should to think about the new plan of sectors to design sectors. Thank you for attention.